So Microsoft drops a new research paper called Orca 2, teaching small language models how to reason. This is building on their Orca 1 model, which at the time of its release, I missed. I listened to a few podcasts about it that I will share with you right now, and then I kind of forgot about it. Looking back on it now, that was a mistake because this is big. There's some big implications here that you should be aware of. The reason it's important is as I'm recording this, we just got through the crazy weekend of OpenAI, hostile takeover, OpenAI potentially merging with Microsoft, the board resigning. Depending on when you're watching this, I'm sure a million other crazy things have happened by that point. But I think for a lot of people, that reinforced the need for high quality, effective open source models. The idea that there's just one model that is the most powerful in the world and there's nothing quite like it, and it's behind closed doors controlled by people whose intentions sometimes we don't know and don't understand. I'm talking about the board of OpenAI, which at this point we have no idea what their thinking was when they were doing what they were doing. But the point is you don't want to be reliant on a very small group of people whose goals might be very different than your own. One of the really exciting things about Orca 2 is that it really shows that open source models can be extremely effective, easy to create, very accessible, and much smaller, but at the same time better than we previously imagined. So let's dive in really quick. So this is the podcast I was listening to back in September 14, 2023. That was right around the time Orca 1, that paper came out. So this is Microsoft Research Podcast, AI Frontiers, the Future of Scale. And so it looks like Ahmed Awadallah, I'm guessing that's this guy, and he's on Orca 2. That's his name on this paper is one of the names, and he's one of the people on this paper. So he talks at length, but I think the fourth question down that he answers is specifically about what they found in Orca 1 as it relates to the quality of data. Now, the quality of data for training these models, there's a lot of questions surrounding that. Basically, the ability of the AI models to do what they're doing largely depends on what we train them to do. We show them a billion pictures of dogs and they're able to figure out what dogs look like. We feed them tons of textbooks and they're able to answer questions about textbooks. One concern was, are we at some point, will we run out of high quality human generated data, right? There's only so many things written. There's only so many books, so much information that's out there. Some of it might be high quality. Some of it might be low quality. You can think of textbooks as being high quality and political discussions on Twitter being low quality, for example. And the potential solution that a lot of people were thinking could be used is synthetic data, meaning data generated by these AI models. So if ChatGPT produces 10,000 books on biology, can we teach another model to read those 10,000 books and become great at biology? Or would there be certain compounding issues and errors that degrade the performance when we're using synthetic data? So keep that in mind. Synthetic means AI generated. So in other words, like if this AI, we humans, we give it some data enough to get it rolling, and then it just starts generating its own data, kind of like building upon itself recursively. I mean, that would be the ultimate sort of ability for us to scale up how well these models do. Here's what they found. So I'm going to take this and I'm just going to, you know what I'm going to do? I'm going to put it into ChatGPT until it just summarizes it for me. So here's a couple important points out of that answer that Ahmed gave us. So the first thing is they're saying that the paper Orca, it emphasized the importance of data quality over the sheer number of parameters or tokens in language models. And this has been said by a number of people. The founder of Stability AI says that. So they're saying the stuff that we feed this model is much bigger than the size of the model, which again, if we're talking about who has access to these models, is it the greater public, the people, or is it just the biggest, most gigantic AI labs that have the resources to compute? If it's just about size, then the people with the billions and the trillions of dollars to build these models, they will control them. They will control the most powerful ones. If it's about data, it's not quite as clear cut, but potentially good for the majority of people. Another thing that they talk about in the paper is the concept of progressive learning. So similar to how with human kids, right? We start by teaching them simple things and slowly advance over time. That seems to also be an idea that works very well with teaching these AI models. They also talk about transferring knowledge from larger to smaller models. We'll talk about that in just a second. They talk about GPT's 4 role in teaching. So can GPT-4, the most advanced model that we have, as far as we know, can it teach smaller models to be like itself? Can it improve them to be closer to its own capabilities? And here's the data component on it. So synthesized data. So data that is made up or created by, let's say, GPT-4. They're saying GPT-4's capability to generate high-quality synthetic data is highlighted. highlighted, but I can't highlight this. There we go. It could not highlight it for some reason. This synthetic data can sometimes surpass human generated data in quality, which is incredible. It means these models can create better data than we could have, which this combined with the fact that data quality is very important, it's a big deal. We'll talk about it in just a second. We'll come back to it. And then there's a few more points that we'll cover once we look at the Orca 2 paper. But I think the big point, the exciting point, and again, time will tell. We don't know, but it sure seems like AI progress can continue in many different directions, meaning that we can improve the models by making them bigger. We can improve the models by making them more specific to a task, so they can be very small and easy to create and really great at one particular task. We can have the bigger models train and teach the smaller models. We can improve these models through better data that they themselves can generate better than humans. So in other words, it's not like it's just about more compute, more chips, more NVIDIA microchips being cranked out. Yes, that's one great way to scale up AI, but there's a million other ones. So let's take a look at this. So Orca 1, so that's the paper that was released, 5 months ago, I would say, learns from rich signals such as explanation traces, allowing it to outperform conventional instruction-tuned models on certain benchmarks. So in Orca 2, so that's the paper we're talking about, we continue exploring how improved training signals can enhance smaller LMs' reasoning abilities. And LMs is language models. So these AI models that are able to talk and reason and do stuff. So previous research on training these small models, they relied on it just kind of imitating the larger models. And they're saying that while that may have worked, it restricts how much these small models can do, how much they can learn. And they're looking how to teach these small LMs to use different solution strategies for different tasks, potentially different from the ones used by the larger model. So I've covered this paper in a previous video called Language Models as Tool Makers. And basically what it's showing, so tools they're talking about here, they're talking about code, they're talking about certain scripts. And so what that paper showed is that the larger, smarter model, GPT-4, can create tools, can create certain pieces of code that it hands off to a faster but less capable model like GPT 3.5 Turbo. And then that smaller model can sometimes perform certain tasks as well as the GPT-4 could. So it's interesting to think about. Like imagine this big brain that's capable of doing a lot of different stuff, but it's slow, costs a lot of money to run, but it can spin up these fast little versions of itself, give it some pieces of code, and then that thing can perform specific tasks just as well as the big brain can. This is a big concept because it gives us kind of a hint into what AI will look like, right? It's not going to be this one thing, this one generic blob that does everything. Most likely it's going to be kind of resembling a swarm, like an insect swarm, right? So you have the queen, the GPT-4 or whatever, the best model that we have. And as it needs certain tasks completed, it creates these little agents that go and do that thing. Those agents don't have to be generally smart. They don't have to be as good as the big model at everything. So I think conceptually, more and more stuff that's coming out, it's all kind of hinting in that direction. It's not one big thing. It's a swarm of little things with potentially one sort of main GPT-4 or whatever, kind of controlling them and spinning them up as needed, creating them as needed to complete those subtasks. So in Orca 2, we teach the smaller models, various reasoning techniques, and we'll go through them in a second. They're step by step: recall, then generate, recall, reason, generate, direct answer, etc. And most crucially, we aim to help the model learn to determine the most effective solution strategy for each task. So for example, something that requires reasoning might have one technique better. If you're looking at something that does coding, another technique might do better, etc. So they want the models themselves to figure out which technique works where. All right, and this is where we get to the good stuff. I'm going to change my highlighter color to show you how important this is. So they evaluate Orca 2 on various benchmarks. Orca 2 significantly surpasses models of similar size. So similar smaller models, it just blows it out of the water and attains performance levels similar or better than those of 5 to 10x larger models. So this thing is, let's say, 10 times smaller, but produces the same results, as assessed on complex tasks that test advanced reasoning abilities in zero-shot settings. So zero-shot means it hasn't encountered that before. if you want these models to answer a question, you tell them, here's my question, and here are 3 examples of how you can answer that question. So for example, so if you've taken some standardized tests before, sometimes they'll have at the beginning of the test, like here's some examples of how to fill in the circle or how to answer correctly or whatever format to use. So it's just showing it, here's what kind of answers we're looking for. Here's your question, answer it. Zero shot means you don't give an example. You just ask it the question. It hasn't seen examples before and it has to answer it. And we open source Orca 2. So here's an example of, so these are the various benchmarks that they've done, and they're going to dive into each one in greater detail. But as you can see, the left and then the second from the left, those are the Orca models, like these 2 right here, those, okay? So the leftmost one is the 7 billion parameters and the next one is the 13 billion. So one thing that jumps out at me is they're not that different. That's one. They're very similar, even though one is almost twice the size of the other. And 2, they seem like they're either the best ones or near the top. This one, GSM-8K, the Wizard LM, but so this one is specifically built for coding purposes. So this one is better at GSM-8K, which again, we'll dive into it later. But the point is Orca 2 is killing it like a killer whale, no pun intended. All right, so here's an example of a reasoning question. So John and Mark are in the same room with a ball, a basket, and a box. John puts the ball in the box, then leaves for work. So if you've seen these questions before, they're theory of mind questions, is sort of understanding who knows what, who is aware of what, which, by the way, I feel like there's a % of humans that have trouble with this as well. Computers, AI supposedly, as AI is getting better and better at this, it's interesting that there's people that do struggle with this, understanding what people know or they don't know, whatever. John puts the ball in the box, then leaves for work. While John is away, Mark puts the ball in the basket, so he moves the ball, and then leaves for school. They both come back later in the day, and they do not know what happened in the room after each of them left the room. Where do they think the ball is? So John puts the ball in the box and then disappears. That means he thinks it's in the box. Mark puts the ball in the basket and then leaves, so he thinks it's in the basket. So let's see how Orca 2 13 billion does this. So John puts the ball in the box and then leaves. Mark puts it in the basket and then leaves. So it kind of summarizes what happened and then starts reasoning about it. At this point, John and Mark have not seen each other's actions. Therefore, they only know what happened while they were in the room. Is this right? John and Mark are in the room with a ball. I feel like Mark witnessed John doing this since they are both in the room at the same time. They are both in the room with a ball. Okay. Therefore, they only know what happened while they were in the room. John only saw the ball in the box before he left for work. That is correct. He put it there. Mark only saw the ball in the basket before he left for school. That's correct. He put it there. Since they did not witness each other's actions, this is wrong, right? Yeah. They would both believe that the ball is where they last saw it. So John would think the ball is in the box. John in the box. Yeah. And Mark would think the ball is in the basket. Mark, basket. So I would say this is correct, although maybe this part is off. But it seems like the reasoning was flawed, but the answer was correct, right? All right. So Llama, the open source model, starts answering the question. The ball is still in the box because it was there when John left the room. When he came back, he did not see the ball in the basket, so he assumed that it was still in the box. It's nonsense, right? It's not really making any sense. And then it goes, question 10. A man walks into a bar and asks for a drink. The bartender says, "I'm sorry, but we don't serve alcohol here." The man replies, "Oh, I didn't realize this place was a church." What does the man mean by his response? And the answer is, this means that the man has been told by someone else, probably his friend, that he cannot have any more alcohol at this establishment. So if you're confused, basically, so these models aren't like chatbots like ChatGPT, where it's like you ask it a question, it answers. These are more text completion. So it seems like here's probably in its training data, there's a sequence of these questions and answers. So it's thinking, okay, once I answer this question, what comes next? Oh, another question, another answer, another question. And if you just let it go, it would just keep listing these things out. What's interesting here is that this question it makes up, it still doesn't make sense. It still, I feel like, gets it wrong. So anyway, so that's a big no. And then there's Llama 2. Okay, so this is the chat. So this is more similar to ChatGPT. And so they're saying this is a classic lateral thinking puzzle. The solution is that the ball is still in the box, right? So it kind of goes through its reasoning and says the ball is still in the box, which is, I mean, whether that's true or not, that's not the question. The question is, what do the two people think? Where do they think the ball is? not where the ball is. And then ChatGPT says, John and Mark likely think that the ball is in the box since that is where John left it before he left the work. So this is kind of what the big deal about GPT-4 was, because that was the first model that started like really grasping these theory of mind questions, right? So before that, as you can see, it's saying, well, where do they think the ball is? Well, it's what's in the box because blah, blah, blah. But the point, it doesn't understand that the two of them will have different knowledge, different sets of knowledge, and one will think it's here, one will think it's there. It's missing that thing, right? Now, if we just copy and paste this into GPT-4, and at this point, this is GPT-4 with vision, the extra context. They call it the 1106 version. So you can see here, it really gets the question. So it starts saying, okay, John's perspective. So he put in the box. So he thinks it's in the box. Mark's perspective, So Mark moved the ball from the box to the basket. So he thinks it's going to be in the basket. So this is correct. The interesting thing is they're both kind of defaulting to this idea that Mark saw the ball in the box when he entered the room. So both Orca and GPT-4 feel like they're slightly off. Either that or I didn't have enough coffee and I'm slightly off, because as I'm reading this, they're both standing there. So John puts the ball in the box. Mark is observing him doing that. So there's probably something in the training data that's throwing them off. Maybe other similar questions have them alternatively have them walk into the room one at a time, move the ball around, the second one comes in, etc. So anyways, so as you can see here, the models that get the question correctly are 1, the Orca, and 2, GPT-4, but not GPT 3.5 or Llama, instruction tuned or otherwise. All right, let's continue. So this is the introduction. So they mentioned that basically AI models are doing wonderful things like coding, web search, chatbots, customer service, content creation, etc. And that scaling them up, like in the case of GPT-4, PaLM 2, as we scale up, we see some emergent abilities that are seen in small models. So new skills that they just emerge as we're scaling those things up. Sometimes they do it very rapidly, surprisingly fast. As some researchers have put in the past, it's unintuitive, and it's surprising, and it's very rapid sometimes. And notably, the remarkable ability to reason zero shot. So being able to solve tasks they haven't seen before, they haven't seen examples of. And those abilities include answering complex questions, solving multi-step problems. They give one example as the US medical licensing exams, on which LLMs now achieve a passing score once these were considered beyond the reach of AI. And so imitation learning has emerged as the approach that we use to improve these small language models. But the problem with that is while they learn how to match the style of the teachers, they don't reason as well. They don't comprehend as well. And they're saying, it's a little bit, it can be effective, but it's not great. So what they are trying to do is they're trying to answer, how can we teach these smaller LLM models? How can we teach them to reason better? So we went over this already in the introduction. So in Orca 1, they utilized more capable LLMs to demonstrate various reasoning strategies across various tasks. In Orca 2, the reasoning strategies are carefully tailored to the task at hand, bearing in mind whether a student model is capable of the same behavior. So to produce this nuanced data, the more capable LLM is presented with intricate prompts designed to elicit specific strategic behaviors and more accurate results. So this is an example of that. As you can see here, you will be given a task, use the following steps to solve it. So we'll come back to this, but they give it very specific instructions how to solve it. So this is given to the larger model. And then the smaller model is exposed only to the task and the resultant behavior, without visibility into the original prompts that triggered such behavior. And they refer to this as prompt erasure. So this is really interesting. So they take this big smart model and they, in excruciating detail, explain to it how to solve a particular task. They go step by step, they explain everything, and that prompt that they give it, how they phrase their request, is very carefully considered and kind of optimized to get the best possible result. And then the big smart model answers and says, okay, here's my reasoning and here's the answer. That then becomes the data on which the smaller model is trained. So we take the answer and we give it to the smaller model. But the smaller model does not see the careful, structured prompt that we trained the larger model with. I got to say, that's seems pretty brilliant. All right, so this prompt erasure technique makes Orca 2 a cautious reasoner. And we'll come back to cautious reasoner because they've mentioned this multiple times. This is another sort of a key term that's going to be important. So because it learns not only how to execute specific reasoning steps, but also to strategize at a higher level how to approach a particular task. Rather than naively imitating powerful LLMs, we treat them as a reservoir of behaviors from which we carefully select those best suited for the task at hand. So it's important to understand what this is saying. Imagine a future where one mega massive company owns the world's greatest AI chatbot, but it's completely closed source. No one has access to it. What this is saying is that you, sitting at home, will be able to create smaller models made for specific tasks just by prompting this big closed model. You're able to kind of like copy and paste certain aspects of its abilities by having it create the curriculum, the training for the smaller model. And we believe that the same techniques we've applied for reasoning could also apply to aligning models for safety. That's not an important thing. That like really what the governments right now are talking about is regulating the big models. They're trying to limit how big of models we can train without having some sort of government oversight, etc. But these tiny models are probably a lot safer because they can't do everything. They're really good at this one thing, but not so good at anything else, right? They're great at math, but they can't button their shirt. We note that instruction tuning, while very beneficial for teaching the model how to solve a task, does not necessarily teach the model new knowledge. Hence, instruction-tuned models will always be limited by the knowledge learned during pre-training. This is especially important to understand when we're talking about smaller models. As such, smaller language models with enhanced reasoning are perhaps best used as reasoning engines. I'm actually very curious who was the first person to start using that word, reasoning engines, over knowledge provided to the model in its context window or when specialized to narrower domains. So this is huge because, again, I think a lot of people that hear about these AI models, from the news or from sort of like general sources, like they think of them as, oh, they're just chatbots. They chat with you. I think the thing that a lot of people that aren't like deep into the stuff, the thing that they're missing is that these models are reasoning engines. And so we already have a lot of software that does a lot of automation and does a lot of cool stuff, but we've always missed that little special sauce of actually be able to broadly reason about stuff. And that's where these neural nets, these AI models come in, because they can be that reasoning engine that powers a software system that allows it to do a lot more. And we've covered a number of examples on this channel, Minecraft Voyager, pretty much anything coming out of like that NVIDIA research team, like those agents that are able to do pretty crazy stuff in virtual worlds with just a GPT-4 that's kind of just making all the decisions. And then we have explanation tuning. So this is where, the smaller models, if they're taught by larger models, they generate stylistically correct answers, but they're wrong. The outputs are wrong. All right, section 3 is teaching Orca 2 to be a cautious reasoner. And this is a new term that I think they're using here, cautious reasoner. And so here they give an example where different system instructions yield very different results. So they give an example here using GPT-4. They give a question of story reordering. And so the first answer, the default GPT-4 answer, is wrong. The second answer, they've prompted it to do chain of thought reasoning, is better. We can see that the model is reasoning with step by step, but important details guiding the decision process are still missing. The third answer with explain your answer prompt is wrong, but the explanation is correct. The final answer is the only correct answer and is obtained using the following system instructions. You'll be given a task, use the following steps to solve it. Identify the main theme or topic of the story. Look for any cause and effect relationship between the sentences. Find a sentence that could be the start of the story. Go through each of the answer choices and analyze to figure it out. Rearrange the sentences in the correct order based on the information gathered in the previous steps. And 5, final answer, write down the correct order of the sentences using their numbers, such as 2, 3, 4, 1, 5. All right, so the point here is that GPT-4 responses is really how good they are is based on the instructions you give it. So these are the instructions that produce the best answer, the correct answer, right? So they're saying without such instructions, GPT-4 may struggle to recognize a challenging problem and might generate a direct answer without engaging in careful thinking. So this is important. So basically, sometimes when a challenging problem presents itself, the AI doesn't immediately recognize that it's challenging. So it's like, oh, it's this, right? Have you ever had that? Somebody asks you a question, you give your first sort of gut answer, and they're like, well, what if you think about it? Think through it a little bit more. Then you think about it, like, oh, wait, yeah, you're right. It's more complex than it appeared at first glance. And so for training Orca 2, they've created this data set with 817,000 training instances. So that's the Orca 2 data set. That's the thing that was trained on. And the prompts are synthetically generated, meaning that they are AI generated. That's important to keep in mind here, as we talked about before. this isn't human generated data. This is synthetic AI generated, and we use that data to train the smaller model, the Orca 2. And so in conclusion, our study has demonstrated that improving the reasoning capabilities of smaller language models is not only possible, but also attainable through training on tailored synthetic data. This, I think, is a big deal. That's kind of the headline here. Orca 2 models, by implementing a variety of reasoning techniques and recognizing the most effective solution strategy for each task, achieve performance levels comparable to and often exceeding models that are much larger, especially on zero-shot reasoning tasks. So again, this is big news for, number one, creating synthetic data to train the models with, for very small, inexpensive, accessible models being extremely good at very specialized tasks. So meaning that you're not going to necessarily have to pay whatever a large company wants you to pay for API usage. You can use them to train your own open source, cheaper model for specific tasks. As long as you can use the bigger model to generate that tailored synthetic data, it seems like you can create these smaller models. And again, I feel like if one person creates synthetic data that is of good quality and shares it with everybody else in an open source way, it seems like then anybody can use that to create their own. And again, this is good for safety because we don't have to use the biggest, smarter models for everything. We can create more capable, smaller models that pave new way for new applications that require different deployment scenarios and trade-offs between efficiency and capability. Well, this is exciting indeed, and let's see where this goes. It seems like we're moving towards a world where open models can be very powerful, tailored to whatever you're doing, making them very accessible to anyone for whatever tasks that they're going to want. Also, the fact that we can effectively use synthetic AI generated data to do that kind of knocks down another roadblock that we thought that we might have. Anyways, I thought that was hopeful. Thank you for watching. If you're still with me, you're a trooper. Congratulations. Thank you. My name is Wasraf, and I'll see you next time.